Good morning, viewers at home. This is Mathematics with Dr. Oj. In this video, we shall study indices. Please don't forget to subscribe to my video channel by clicking the subscribe button below the video and the notification bell so that anytime I upload new video, you'll be duly notified. Thank you. Rule of indices. We shall look at the rules that guide indices. First, if you have x raised to power a multiplied by x raised to power b, see, that is the numbers, the values, the variable up are called powers. X is an integer here to the power of what? A multiplied by x raised to power b. We treat x as an integer variable while we have a and b as powers. So it's because x raised to power a multiplied by x raised to power b will be x raised to power a plus b. What are we saying here? Anytime you have a multiplication of two index numbers, that is when you are multiplying two index numbers together, so the powers of the index numbers will what? Will be changed to addition. That is, when you multiply, you add the two powers together. When you multiply the two index numbers, you add their powers together. Because that we have x raised to power a and x raised to power b here. X is common to them. You pick x, then you now add the powers together. So multiplication sign will change to addition sign for the two powers. Same here. The difference is just that in this case we have division sign between the two. So what you do here is you pick x, which is the common integer there. Okay. Now you now subtract b from a. That is x raised to power a minus b. And here you have x to the power a. You open the bracket and multiply it by the power b. When you see an index number that has this kind of form, where you have another power outside the original power it has, so what you just need to do is to multiply the two powers together, multiply a and b together. Okay, you are not adding here. Why? Because the kind of we have put a barrier between a and b, and the barrier there is multiplication. You can see that x raised to power a is in the bracket, then we put b outside. That's why it is what? It is multiplication a, you multiply a by b. Now here we have x raised to power 0. So in indices, anything raised to the power of 0 is 1. Anything raised to the power of 0, be it 1 million raised to the power of 0, your result is 1. Okay? Now the next one, x raised to power negative a. You can see that our power here has a negative sign. So anytime your index number has a negative power, so what you need to do is that if you want to transform it, that negative sign will be written as 1 all over. It will be a reciprocal or an inverse of the what? Of the index number x raised to power a. So x power minus a will be what? 1 all over x to the power of a. Please don't forget that. Now the next one, the sixth one, x raised to power 1 over a. You can see that the index number here has a fractional power. Okay, we call it fractional indices. Now what you do is this: just pick your x is already the integer variable. Now you can see that your a happens to be the denominator of the power. So that denominator will be the roots, number of your x. That is, you can see that a happens to be the what? The denominator is outside the root sign. So we have a roots, a root, or it depends. This a could be anything, but that's a roots what? X. The x will come in, and the one here is written on top. The one here has become the new power for the integer variable inside the root sign. So look at number 7. You see that number 7 is very similar to number 6. It's very, very similar. It's just a modification of number 6. Okay. Now we have x raised to power a over b. So like I did in 6, you know that the denominator of my power here is taken outside the root sign. So we take b outside the root sign, then the square root of what? X raised to power of a. So a replaces 1 that we have here. Okay, very good. So now the last one is if x raised to power a is equal to x raised to power b. You can see that x is common to both. Now both are still they're also equal. That implies that your a is equal to b. So anytime you have index numbers that are equal in ranks like that, the powers will also be what? Equal. Okay, so now let's look at examples. Let's look at some examples. Okay, let's look at some examples. Suppose we have simplify. Example 1. Example 1. Let's write simplify the following. Simplify the following. Okay. Simplify the following. 1. A raised power 2 multiplied by a raised power 7. 2. We have 3x raised power 4 multiplied by 2x raised power 6. And the 3, we have 2b raised power 3 multiplied by raised power 4. Then we have 5x raised power 4 divided by 25 x raised power 7. And I think that is that for that. Let's quickly solve this example. Let's solve the example first before we go to another examples. Okay. Now, how do we solve this? Solution. Okay. Now, if we look at this first question, it's very similar to the first rule I just gave you. So here we have a raised power 2 multiplied by a raised power 7. Okay. You see that this is an indices. It's an index question. So you can have a raised power 2 multiplied by, your a is common, you pick a. I told you, when you have index numbers like this, which are supposed to be multiplied together, so what you do is what? You add the powers, 2 plus 7. So that will give you a raised power 9. You just add the powers together. It's as simple as that. Okay. Now the second one, 3x raised power 4 multiplied by 2x raised power 6. This is just a modification of the first one. Now you can see that we have integer here, 3 and 2, before we have our integer variable x. Okay, so what do we do here? So we just multiply 3 by 2 first. That's 6. Is allowed me 6 raised to the power 4 multiplied by x raised to the power 6. Okay? Now I have 6. Pick one of the x's, x. Then I told you, you are to, when we are multiplying index numbers, you add their powers. 4 plus 6. So that will give you what? 6x raised to the power of 10. Okay, that is that about that. The third one, 2b cubed raised to the power 4. Yes. So now how do we go about this? You have to be careful here. Because why? Because you have an integer variable. I mean, you have an integer too. So that integer is, this one is saying that 2b cubed times 2b cubed times 2b cubed times 2b cubed. It means they are multiplying 2b cubed in 4 places. So I know that 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that's 16. Now b is common to them, and b is an integer variable. So pick b. It's not a number. It's not 2. If it's a number, it should be multiplied out. Now it's not a number. Now if you have b, then your 3 plus 3 plus 3 plus 3. Because 1, 2, 3. You have 4 3s there. So that will give you 16b raised to the power 12. Okay? Now that is one. Another way of solving this. Alternative way of solving this, which is as simple as that one. Now you can say alternate method. This one is faster. This one is faster than that one, because this one will take your time. But just for you to understand the way this one is done. So you have 2b cubed raised to the power 4. Okay. Now, just by the time you expand now, it will what? 2 raised to the power 4. That is, this 4 belongs to 2 as well. It belongs to b cubed. It belongs to 4. Then b cubed raised to the power 4. You can see both of them have shared the powers of 4. And 2 raised to the power 4 is 16. Then b, then 3 times 4, as I told you the previous rule. That's 3 times 4 is 12. Okay, so that is that about that too. Now the last one here, number 4, our question. I think number 4 is 5x raised to the power 4 divided by 25 x raised to the power, I think it's what do I have here, 2 or so. Is it 2? 7. Okay. Now 5x raised to the power 4 divided by 25x raised to the power 7. Okay. How do we solve this? How do we solve this? Now you apply one of the rules of indices, and the rule you're going to apply here goes for rule 2. Now this one, do you know that this one means the same thing as 5x raised to the power 4 all over 25x raised to the power 7? Do you agree with me? Because division means it's a ratio of fraction. Okay, so with that, you can get anyway, it depends on how you want to, or you can write it like 5 all over 25. Okay, notice 5 over 25. Yes, picking out the numbers there, 5 over 25, then you have x raised to the power 4 divided by x raised to the power 7. Do you agree with me here? Yes, 5 all over 25, x raised to the power 4 divided by x raised to the power 7. So 5 over 25 is what? 1 all over 5, then x raised to the power 4 divided by x raised to the power 7. Then you have 1 all over 5. Are you with me? Then x raised to the power 4. Now don't forget, division will change to minus the powers, minus 7. So you have 1 all over 5, x raised to the power what? Minus 3. Okay? You can leave it like this, but it's not too mathematical if you leave it like this, because you can transform this x to the power minus 3. So this one will now become to 1 all over 5 times. Now, don't forget about the index power. Negative power. Now, the negative sign here means what? 1 all over, then x raised to the power 3. Okay. So now multiply out. You have 1 times 1. You have 1 over 5 times x to the power 3. 5x raised to the power 3. So you can leave it like that. You are safe. Okay. You can leave it like that. If you leave it like that, you are very, very okay. So on this note, we come to the end of the solution to the problem. So don't forget to subscribe to my video channel by clicking the subscribe button below the video, and don't forget also click on the notification bell so that anytime I upload the video, you'll be informed. Thank you very much.